Hello, now we're going to look at lines in the data. And the first word we need is a regression line, and that's the line used to predict y values from given x values. And the regression line, there's many different types of regression lines. The regression line that we're going to use mostly in this class is called the least squares regression line. It's the line of best fit. Um, is line of best fit is the line for which the sum of the squares of the residuals is the lowest. So here's our equation. We write y hat. We put a little hat on our y, meaning that we're predicting our y based on our x values. And whenever we do this, we want to make sure we clearly label our variables. So say what x means and say what y means. And I'll explain that in a bit. Now, if I wanted to make a graph, I'll take out fathom, and I have my variables, and I'm going to put the beers here, and I'm going to put the blood alcohol content here. And so now I have a nice graph. Now if I want, I could go and add a movable line and move it in here. And this would be a regression line. Wherever I think the line should be, that's a regression line. And so if I wanted to show the squares, so if notice how each point goes straight up and this distance is the residual. If I make a square out of that, um, if I decrease the amount of the squares, um, that the smallest sum of squares is our least squares regression line. So 0.1, now we're at a 0.09765. That looks pretty good. Oh, then it started going up. So somewhere around there. And can I modify it to get below 0.58? Looks like 0.58 is pretty low. So now the sum of all those squares, so if I add up all the area of those squares, it's pretty low here. Now if I want to check to see how accurate I am, I can go up here and just click on least squares line. And least squares line is the 0.05850, which is just a tiny bit smaller from what I figured out just by playing around with it. So this is actually the least squares regression line. And notice how they use the variables, uh, the blood alcohol content, how they predict it based on beer levels. So if we wanted to do that with our calculator, so I have this graph up from the previous lesson, and now I hit Stat, go over to Calc, and I go down to linear regression. And typically what we want to do, if you go down to 8, notice how 4 and 8 are very similar. The only difference is on number 8, they use b as slope, and we're going to use b referring to slope a lot of times in this class. So I typically like to do number 8 so it doesn't confuse people. And we want list L1 and L2, and so we can just hit calculate, and now it gives us our A value and our B value. So now to write your least squares regression line, blood alcohol content is our Y value, and we put a little hat above that, so because we're predicting our blood alcohol content. And that's going to equal negative 0.0127 plus our slope, which is B, 0.01796 times our X value, which is, let's just call it beers. And that's how we find your least squares regression line with a calculator. Now, interpreting the slope and Y-intercept is a common thing for us to figure out. Let's turn on both pages so I can see it. So to interpret the slope, what this means is for every increase in one beer, the blood alcohol content is going to predict to go up 0.017. So for each beer consumed, blood alcohol content is expected to rise 0.01796. Now our y-intercept is over here. To predict that, what that means is if we have 0 beers, our blood alcohol content would be negative. Now that doesn't make any sense, but we'll write it anyway. If we have 0 beers, we would predict our blood alcohol content to be negative 0.0127. So, so this doesn't make sense, and the y-intercept doesn't always make sense in the context. And it's good to note that because um, there's no way your blood alcohol content can be negative, as far as I know. All right, now here's that data that you had before. I want you to find a linear regression and draw it on a scatter plot. Ooh, I forgot to draw it. Before we move on, to draw this on a scatter plot, there's two things that we need to do. We need to put 2 points into the equation and find out where they're going to end up. Now, there's a couple ways that we can do this. One is to just plug a number in for beers. Say, it's good to do one on the left-hand side and one on the right-hand side. So if I plugged in 1, see what my value is, and then plugged in 10 and see what my value is, then we can draw a line from there. Another way we can do it is if we do a linear regression again, and now when it says store regression equation, if we type in y1, so I hit second vars, oh sorry, just vars, go to y vars, enter, enter, calculate. Looks like nothing happened. But what it did is it threw the y1, or threw this into the y1 variable. Now, when I graph it, you can see the linear regression line on the graph. So if I want to find the values, I can hit second trace and value. If I put in x equals 1, it tells me that that is 0.005. So 1 is 0.005. So that's right about there. Pretty close to that point, because um, 0.001 would be here, maybe a little bit lower. And now if I want to do 10, now I do that again, second trace, which is calculate, value. If I have 10 beers, oops, let's do x equals 9. 10 was off the screen. So 9 beers, that's 0.148. So there's the 0.9.148. So 9.148 is right up here. And once I have those 2 points, then I can connect them with a line. So that's how you draw your least squares regression line. You pick 2 points, and we could have just thrown in a point for beers, got an answer, thrown in 1, thrown in 9, and we could do the same thing. All right, now try this on your own. Find the linear regression and draw it on your scatter plot.